This case study deals with corrosion found in the vertical fin attachment tension bolt holes during a scheduled C check. The vertical fin is attached to the fuselage through multiple high-strength tension bolts located in the crown area. These bolts transfer aerodynamic side loads from the vertical stabilizer into the fuselage structure. Corrosion was detected inside bolt holes. Since this is a primary structural attachment, any material degradation in this region directly affects load transfer capability and residual strength. Therefore, inspections and corrective actions were required to maintain structural safety. Multiple bolt locations were affected, meaning the issue was not isolated to a single fastener but involved several attachment points. This increases concern because load sharing between bolts may be disturbed. Sealant condition plays a major role in corrosion protection. If sealant degrades or moisture enters the joint, corrosion can begin inside bolt holes where it is not easily visible. Bolt hole degradation reduces the effective cross-sectional area of the joint. Since bolts transfer tension and shear loads, any material loss directly reduces joint strength. If corrosion progresses without detection, the structural integrity of the fin attachment can be compromised, which could affect aircraft stability and controllability because the vertical fin is essential for directional control. This case study teaches important structural lessons. Environmental protection is not secondary. It is part of structural integrity. Primary attachment structures must be protected from moisture and corrosion. Corrosion can be as critical as fatigue. Even without cracks, material loss alone can reduce strength below safe limits. Attachment design must consider long-term durability. A joint must remain safe for decades under load and environmental exposure, not just when newly manufactured.